Hey everyone, today we're looking at the paper CTRLsum towards generic controllable text summarization by authors from Carnegie Mellon University and Salesforce Research. A standard approach to train abstractive summarization systems is to provide an input article to the model and to train the model to generate a reference summary. Using a large dataset of articles and summaries. However, one limitation to this approach, which the authors of this particular paper explore and try to improve on, is that the summarization model doesn't have any information regarding which parts of the input article are most important to the user. And it might be desirable to build models that allow a user to provide some extra information, such as a set of keywords, let's say the names of the specific people who are part of this article, such as Dwayne Wade here in this basketball article, and to have a model capable of focusing the summaries in the direction of those keywords. And this is precisely what the authors do in this paper. Their model CTRLsum is taking as input not only the article, but also one or multiple keywords extracted from the article as an additional training signal, or some sort of a control tokens as they call them. And these keywords could be coming either from a user of the summarization system who is interested in steering it towards a particular direction, or they might also be automatically extracted from the article using a different model, keyword extraction model. And in both cases, the authors show that inputting those keywords leads to improved summarization performance on a number of datasets, including news articles, scientific papers, patents, and so on and so forth. And here we have some examples where you are providing Dwayne Wade to the summarization model and you're getting a summary which includes some information about what Dwayne Wade did in this particular article, which is he scored 21 of his 32 points in the first half. And you can also have some other keywords and you get some different summaries. So this is how the approach works in a nutshell. Basically, they are, to give you some more information, the authors extract those keywords and then they prepend them in to the input sequence using some special tokens as separation. And during the training, they are detecting the most likely keywords using the reference summaries by computing some overlap scores. During inference, precisely there are two modes, the automatic keyword extraction mode and the manual mode. So looking at some results, first on the CNN DailyMail dataset, which is a standard summarization benchmark focusing on news articles, the CTRLsum outperforms the previous state-of-the-art model BART by 1 rouge point or so in the automatic mode, where the keywords are automatically extracted from the article using an additional model, and using a Oracle extraction model, where basically it's taking the keywords from the reference summary. So this is the mode where you assume that there's a human user knowing what he wants. So when he's inputting, knowing what he wants, we're getting an even better performance, superior performance over some other works from this paper, for example, which explore a similar direction. The authors also apply the model to a number of other datasets, such as scientific papers and something related to question answering, which you can read more about in the paper, and to I think that's patent summarization of patents. So in overall, this is a really interesting approach. I was quite surprised that the model achieves high summarization performance superior to the default one, both in the automatic and the manual setting. Because if you think about it, in the automatic mode, when you're just providing an article, the summarization model should be doing something like automatic detection of the most important parts of the article to generate the summary, because it sees both the article and the summary. However, somehow this additional keyword input seems to be beneficial, which is interesting. It might be because really focusing on these couple of keywords really forces the model to be very specific regarding when generating the summary, which seems to be beneficial. So in overall, this is a really interesting approach, which seems to be very successful. And check out the paper for more info, and I will talk to you in the next video. Ciao.